Hey, it's John here from Remotify.io. In this video, I'm going to walk you step by step through how to build a custom Ableton MIDI remote script for your own MIDI controller using Control Surface Studio 3. Everything will be done visually without needing to write a single line of code. I'll be building an example script for the MIDI Fighter Twister, but you can follow the exact same steps to create a script for pretty much any MIDI controller. Here's the functionality you'll be creating in your script. Firstly, you'll control the volume on the selected track. So each time you change the selected track, you have instant control of the volume. And this mapping will also send LED feedback to the encoder. Next, we'll add a custom red box with clip launching using the top 4 buttons. And then we'll add navigation for the red box using an encoder to move left and right. And these 2 buttons in the middle to move up and down. And then we'll add volume and panning to these 4 encoders for the 4 tracks on the red box. We'll have them set as volume, and then we'll add this button in the bottom left corner to switch panning, and then back to volume. These volume and panning controls will be locked to the position of the red box. So if I move the red box, you can see the LEDs updating, and then you can see that I'm still controlling whichever 4 tracks are highlighted with the red box. And then we'll turn on and off an LED, which will be this LED in the bottom right corner, on your MIDI controller when a specific event happens in Ableton. In this example, when playback starts and stops, we'll turn this LED on and off. And then we'll use this encoder in the bottom left corner to control the first parameter of an auto filter device on the selected track. So on this track, I have the auto filter, and I'm already controlling the first parameter of it, which is the frequency. I can select another device, and I'm still controlling it. I can change the order of the devices, and I can delete devices, and then change track, and I still have control of the instance of the auto filter. You can't do any of this using Ableton's internal mapping mode. They all require a MIDI remote script to achieve, which used to mean you needed to be an expert in Python coding, but with Control Surface Studio, you can create these scripts without needing to write a single line of code. You visually add the mappings that you need in the app, then Control Surface Studio generates all of the required code directly into Ableton for you. Are you excited? Great. Let's get started. So I'll log in. As this is a brand new installation, I don't have any scripts yet. So I'll click here to add a new script and give it a name, and then open the script editor. It's important for you to understand the separation between mappings and controller inputs. On the left panel is the mapping table. This is where all of the Ableton specific mappings included in your script are stored. The right panel is the controller template area. This is where the MIDI data for all of the physical inputs on your MIDI controller are stored. The reason for this separation is that controller templates can be created once and then reused with multiple scripts. This avoids the need to reconfigure the MIDI data for your MIDI controller each time you create a new script. Currently, we have a blank script with no controller template attached. So the first thing I'll do is create a new controller template. To do that, I can click on here and I'll give it a name and then add it. So you can see on the right hand side that this is now changed to the controller template user interface. I'll add an encoder which will be a representation of this encoder on the bottom left corner of my MIDI fighter twister. So I'll come up here to the menu, just expand that a bit. You can choose from all of these different controller input types. I'm going to add an endless encoder. You can play with the position and the size of this. So I'll open the settings form for the encoder. What we need to do here is add the correct MIDI data for this encoder. So the quickest way to do that is to turn on the MIDI learn and then move the encoder. And you can see that the MIDI data was updated. And it also displays here the last MIDI data that was received. So as I turn the encoder, you can see the velocity value is updating. If I was to select a different encoder or press a button, you can see all of the other values changing. So this is the one that we want. I'll turn that off now. And then I need to scroll down and change relative to absolute, because this is an absolute encoder. I know that because the velocity value goes from 0 to 127. So I just need to make sure that the first and last values in here match the first and last velocity values that are output by the encoder, which they do. So that's fine. Click Save. Now to confirm that I've input everything correctly, if I turn the encoder, you can see that it highlights in green. That is set up correctly, and I can save those changes to the controller template. Now I'll add a mapping, which will be the selected track control mapping, and I'll attach this encoder as the controller input for the mapping. So I open the mapping menu, scroll down to track volume, and here is where the controller input is selected. As there's only one controller input available, it's automatically selected the right one. But if I was to add some others, I'll have a button and a knob there. If I go back into the mapping, you can see that they're available to select here. So let's just delete those. And then back into the mapping settings form again. I can leave everything else set as it is. And then for track type, I'm going to choose selected. As I want the encoder, when it reaches the very right hand side, I want the volume on the track to stop at 0 dB. So if I leave this set at 85%, that will set the volume to 0 dB. And I'll click Save. The settings done for that. And then the next thing I want to do is to generate the script into Ableton Live. But before I do that, because I haven't set the app settings up yet, I'll just need to quickly do that. If I go to Applications and find the version of Ableton Live that I'm using, which is Ableton Live 12 Beta. It's automatically selected the live version folder location and the MIDI Remote Script folder location. I then just need to select the right version of Ableton Live, so I can check which one I'm using by going to the Live menu for Ableton and selecting About Live. So I'm using 12.2b16, and then I'll just find that in the menu. 12.2b16. That's automatically selected the correct Python version and the correct log.txt location. Everything else can stay the same. So that's saved. Now we can generate the script into Ableton Live. As this is a new script, I'll need to close Ableton and reopen it. I'll now go to the settings menu. If you're using Live 11 or below, this is called the Preferences menu. Then open the MIDI tab Here I'm going to connect my MIDI remote script to the MIDI controller within Ableton Live. This only needs to be done the first time you add a new script. After that, you can simply reload the script each time you make a change. First, find your script in the Control Surface menu. It'll be prefixed with the letters CSS. This is done so that you don't accidentally override any of the default MIDI remote scripts by naming it the same as one. Then select the MIDI controller for the input and output, and then select both track and remote for the input and output ports. When I select a script built with Control Surface Studio in the Control Surface menu, a yellow status message appears at the bottom. This displays whenever you load or reload a CSS MIDI remote script, and it confirms that the script was loaded successfully without errors. So if I select a different script and then reselect my CSS script, you can see that the status message appeared at the bottom. We have full details on the steps to check if your script doesn't work. See the link in the description. Everything looks good here, so I'll close this. Now if I turn the encoder, you can see that this track volume here is moving, and that is the selected track. To confirm that it is controlling the selected track and not just track 2, select a different track. And that works as expected. And then if I move the volume up and down directly in the UI, you can see that the LED feedback is updating on the encoder. And when I change the selected track, the position of the volume automatically updates on the encoder as well. So that's all of the initial configuring done. You now have a working MIDI remote script set up to work with your MIDI controller. And now you can start expanding it by adding more controller inputs to the controller template and more mappings to the script to use with them. And now each time you make changes to your script, to see the changes in Ableton, all you need to do is click the orange Generate into Ableton Live button, then switch to Ableton and reload the MIDI remote script. Reloading scripts can be done by either closing and reopening Ableton Live, or by clicking the Reload MIDI Remote Scripts menu option. By default, the mapping will send LED feedback to the same MIDI data that you set in the input settings. But we do also have another section which is specifically for LED feedback. You set that to custom, and then you can choose a different set of MIDI data to send the LED feedback to. This MIDI controller uses the same set of MIDI data to send and receive, but some controllers do use a different set. If I send the LED feedback to this encoder to the right of the one that we're controlling the mapping with, if I see what that is, it's value 13. Click save, and then generate that into Ableton. Then if I switch back to Ableton Live, and I've reloaded the MIDI remote script. Now when I turn the volume, you can see that this encoder to the right is actually receiving the LED feedback, and not this one. Control Surface Studio provides a collection of pre-built controller templates, including one for the MIDI Fighter Twister. So rather than building the entire template here myself, I'll use that one instead. To do that, I'll come out of the script editor. At the top are tabs for My Scripts, where all of the scripts you've created are saved. My controller template contains all of your controller templates. You can see the template I've been working on is now in here. It tells you which scripts are using the template, which is beginner script. That's the name of my script. I can open the controller template and edit it. Here's the encoder, which I added earlier. I'll come out of the controller template. And then if I go to the On Remotify tab and click on Controller Templates, all of our pre-built controller templates are listed here, ready for you to import and use. I'll import the one for the MIDI Fighter Twister. I just need to find it. And then click on the Import button. A success message appears on the right, which tells me that the controller template was successfully imported. And if I go back to my controller templates, you can see that the controller template is now listed in here. Imported controller templates automatically get this imported and then a number added to the end of their name. I'll just quickly change this by going into the controller template editor and removing that part. And now I want to attach this controller template to my script. So I'll go back to the My Scripts tab and open the script again. And if I open the controller template menu, you can see that the new controller template is listed in here. So I'll select that and it displays on the right. I now want to assign this knob to my mapping. If I hover over it, the name appears, which is knob 9. So I'll open the input menu for the mapping and search for it and then select it. And now knob 9 is selected, and if I hover over it, it highlights in orange on the right in the controller template panel. Next, I'll add a session box to the script. Session boxes, commonly known as red boxes, are used in Ableton Live to visually see which tracks and scenes your MIDI controller is currently set to control. With Control Surface Studio, you can add a custom session box of any size. Along with this, you can also add clip launching plus mixer and device mappings, which are linked to the position of the session box. You can even connect session boxes from multiple scripts together and move them around your Ableton session in sync. To add a session box, select it in the Mapping Type menu. In the session box panel are a number of options. Offset position from the left and offset position from the top set where the session box will be placed when it's loaded. Turning combination mode on will connect it to session boxes in other CSS scripts, which also have their combination mode turned on. And below that are the width and the height of the session box. For this example, I'm going to add a session box which is 4 tracks in width and just 1 track in height. The red box below updates when these are changed. I'm going to add a clip launch button for each track to the top 4 buttons on my MIDI Fighter Twister. So I just need to see what the names of the buttons are. So I'll save this and then check the names of these. Button 2, button 4, 6 and 8. So if I come back in here, I just need to select those. You can also assign buttons for stop track for each track in your session box, scene launch, and stop all, but I'll leave those blank for this script. Below that are a list of clip states which will change the color of the LEDs on the 4 assigned clip launch buttons above when the clip states change. For this example, I'll set clip started to 127, clip stopped to 0, and clip triggered to play to 75. I also edited the LED settings on the MIDI Fighter Twister so that the off color is black. For for those 4 buttons. That's all I need to do for this mapping, so I'll save it, also save the script and generate the script into Ableton Live. Reload the MIDI Remote Scripts. And now I can launch clips. And you'll be able to see the LEDs changing color. If I stop these tracks, you can see that they've turned off. And then when I press them, the triggered state shows and then the play state shows. I now want to be able to move the session box around my Ableton session. So I'll need to add some navigation mappings. For this example, I'll create navigation in 2 different ways. To move the box left and right, I'll use an encoder. And to move it up and down, I'll use 2 buttons. First, if I go back to Control Surface Studio, I'll add the track navigation for the encoder. So to do that, I'll select Session Box Navigation. And the name of the knob is knob 15. In the navigation section, I don't want to select a specific track number, which is what this will do. I'll change this to scroll and leave this set as tracks and leave move by set as 1. You can change this number to whatever you want. For example, if I wanted to move the session box by its width with each turn of the encoder, I can set this to 4. So then it's going to move by 4 tracks each time, but I'll leave it set as 1. And then I'll save this mapping. And now I'll add the scene navigation with the 2 buttons. So I'll need 2 more session box navigation mappings. And it's going to be for button 12 and button 14. So we'll do button 14 first. Set this to scroll again. This time we're going to select scenes. Leave this set as 1, and then in the input control override section, just need to change this to increment and then save it. Then we can duplicate this mapping, and for the copy, we'll set this as button 12, and then we just need to change increment to decrement and save that. Save the script and generate it into Ableton. And then when I reload the script, I should now be able to move left and right with the encoder and move up and down with the 2 buttons. So far, we've added 1 mapping to each controller input. But one of the most powerful things about building MIDI remote scripts with Control Surface Studio is the ability to add multiple mappings to each controller input and then switch between them. This is done using modes. I'll add track volume and panning to these 4 encoders. And then I'll use the modes feature to switch between the volume mappings being active and the panning mappings. A side note, these mappings will be linked to the position of the session box. So I'll add the 4 track volumes and then the 4 track pannings. This option sets the volume to be relative to the position of the session box. So the knob is knob 17. And then the others are 19, 21, and 23. So I'll just duplicate that. I'll call this one volume 1. I'll call this one volume 2, and it's going to be track 2. And then we'll do the same this time for volume 3, track 3, 2, 1, and then the same for volume 4. And then we'll do the track panning, which is the same process. Okay, we can save that and generate it into Ableton. And then reload the script. And now you can see that when I turn each encoder, it's controlling both the volume and the panning on each track. And then if I move the session box to the right, you can see that they are linked to the session box. So the problem is that both the volume and the panning are active at the same time. And this is because they are currently on the same mode. If I go back to Control Surface Studio, you can see that they're all on mode 0. So I'll now need to split them onto separate modes. The modes in your script can be viewed by switching from mappings to modes. Currently we have 3 modes in this script. Mode 0, this is set as the global mode, which means it's always active. Only one of these other modes can be active at a time. The first one in the list will be active when the script loads. I'll rename these. I'll name this one volume mode, and this one panning mode. And then go back to the mappings, and I'll set the panning controls to the panning mode. And the volume controls to the volume mode. I can filter so only the mappings which are on the panning mode are displayed. So it's only these 4. And then I can do the same for the volume mode. So now that they're both on their separate modes, I now need a way to be able to switch between the 2 modes in Ableton. I'll add a mode selector mapping to the bottom left button on the MIDI Fighter Twister. Is it button 24? And 26. And in the mode selector settings, I again want to set this to scroll. Because I'm using a button for the mode selector, I'm going to use increment, which means it will scroll starting with volume mode, it'll go to panning, volume, panning. If I add more modes in here, here we go, volume, panning, new mode mapping, then back to volume, and so on. So I'll generate that into Ableton, reload the script, and now to begin with, the volume parameters are being controlled, and if I press the mode selector, panning mode is activated, and then panning is controlled. If I press it again, we're back to volume again, and then panning. And that will just continuously go round in a loop. And you can see which mode is activated by the status in this bottom left corner. Next, I want the LED on the bottom right button to turn on when I start playback in Ableton, and I want it to turn off when I stop playback. To do this, I'm going to use the reaction mapping type. This gives me the ability to hook into Ableton Live's extensive collection of events and actions via the Live Object Model API. Due to its power and flexibility, using reactions is a more advanced aspect of CSS. Once you understand how to use it, you will be able to build completely custom pieces of functionality in your scripts. For this example, I could use play and stop to send LED feedback to the button, and this would work fine, but using these would also attach the play and stop functions to the button, which I don't want to do in this case. So I'll add a new reaction, and I'll name it reaction playback LED on off, and it's going to stay on mode 0. So I can close the basic settings and the tags, and then in the reaction section. Next, I'm going to add a listener which listens for a change to the status of Ableton's playing value. Which is this one, song is playing. With this listener in place, this reaction will fire whenever playback starts or stops. I can test when this event fires by adding some simple feedback. In the Actions section of the action block, I'll display a message in Ableton's status bar. To do that, I'll select Display a value in Live's status bar. And for the message to display, I'll enter, "This is a test 1." So now this action will display the message that I've entered in Live status bar whenever the song's playing value changes. You can also send messages to the log in CSS, which is, if I just close the reaction, this panel on the right hand side. You just need to make sure that the log is monitoring the correct version of Ableton Live, which you can do by opening the app settings and checking the version that it's monitoring, which is 12.2b17 here, and then go into Ableton and open the About Live menu, and you can see the exact version that you're using. And then I'll go back into the reaction and I'll add a second action which will output a message to the CSS log. So I select display a value in CSS log, and for the message I'll put this is a test 2. Now I'll save that and generate these changes into Ableton, reload the MIDI Remote Scripts, and when I start playback, you can see the message appears here in the bottom left. And when I stop playback, it also displays. So you can visually see that the listener event, song is playing value, has changed, fires whenever playback both starts and stops. And if I check the CSS log, you can see that it's also fired here multiple times. This confirms that the reaction is firing at the times we need it to. Now I'm going to use the conditions section in the action block. So I'll come back into the reaction, and within the action block we also have this conditions section. I'm going to use the condition so that the actions contained within the this action block, only fire when playback is started. So I'm going to select song is playing is equal to true. Only fire these actions below if song is playing is equal to true. I'll just delete the CSS log action. For the live status bar, I'm going to change the message to song is playing. And then I'll save these changes and generate it into Ableton. And then reload the MIDI Remote Scripts. And now when I start playback, the message song is playing is displayed. But when I stop playback, nothing is displayed. Next, I'll add an action which turns on the bottom right button's LED. So I'll open the reaction again and come down to the action section. We don't need this status message anymore. So after adding a new one, I can delete that, and then I want to select send MIDI velocity value to input. And then for the controller input, I want to select button 32. And for the value, the velocity value that I want to send is 127. Then I'll save these changes, generate it into Ableton, and then reload the script again. And now when I start playback, the MIDI velocity value of 127 was sent to this button, which turned the LED on. Just to check it again. So the LED is off. And then when I press play, it's turned on. The only problem now is that the LED doesn't turn off when playback stops. To handle this scenario, I can duplicate the action block. So if I come back into the reaction, here's the action block, and I'll duplicate it. So we now have two action blocks which are doing the exact same thing. In the second one, I'll change the condition so the actions within here only fire if playback is stopped, which I can do by changing true to false. In the action, I want to turn the button's LED off by sending a velocity value of 0. Now I'll generate this into Ableton and reload the script. And now when I start playback, the LED turns on, and when I stop playback, the LED turns off. And lastly, I'm going to give each action block a descriptive name. So if I come back to this in the future, I can quickly see what each of them do without needing to manually look through each step inside them. So I'll name action block 1 if playback started, turn LED on. And then the second one, turn LED off. And save that. For the final mapping, I'm going to do something quite advanced. I'm going to add a device parameter mapping, which is easy enough, but I'm going to create custom functionality to find a specific device by its name and then automatically map the device parameter to it. As this specific functionality isn't built into Control Surface Studio, I'll need to create it myself. So to do that, I'll be using a combination of CSS's tools. First, a reaction. This will search for a device by its name. 2, a modifier. I'll store the device's position number within the device chain to the modifier. And 3, a device parameter mapping, which will use the modifier as its device number. First, I'll add the device parameter mapping. I'll assign the bottom left encoder to the mapping. And then in the track section, I'll select selected as the track. And then for now, I'll leave the device number as 1, but we'll change that soon. And I'll leave parameter number as 1. Click save, and then I'll save the script and generate this into Ableton. Reload the script. So far we can control parameter 1 for the first device on the selected track. But what I want to do is to control the first parameter of the auto filter device on the selected track, regardless of where the auto filter is placed in the device chain. So you can see on this track, we have the auto filter here, which is position number 4. On this track, it's the first device. And then on this track, it's the second device. So I'll go back to the device parameter mapping now. I'll just delete this duplicate. As the position of the auto filter can be different from track to track, the device number will need to be dynamic. So I'll set the device number to be a modifier and save this mapping. Next, I'll add a reaction. This reaction will search for a device named auto filter in the currently selected track and save the device's position number to the M1 modifier. I'll name this find and set modifier value. And then if I go down to the reaction section and open the listeners, this reaction will need to fire when a few different events happen in Ableton. The first is when the script is initialized. Second is when the selected track changes. And third is when there is a change to the devices on the selected track. I need to make sure that we are watching the selected track. So to do that, you open the path menu and then choose selected track. All track and device selection options are located within the path menu. For the action block, we're going to use the loop section to loop through all of the devices in the selected track. So I'll add a loop and select devices. And then in the path menu, I'll choose selected track. And then for each device in the loop, we'll check if the device is named auto filter. If a matching device is found, its position number will be stored to modifier M1. So we'll open the condition section and select device name from here. So you can see there's a number of options for devices. There's also class name, but we want just name for this. And in its path menu, we'll choose selected track. And then for the device number, we're going to choose script loop iteration number. The loop iteration number counts how many times the loop has run at this point. This will match the position number of the device in the device chain. For this, we're going to choose text exactly matches, and then we're going to import auto filter. I'll now add actions within this action block, which will only run if auto filter device name is found. So I'll choose the action set the value of a modifier, and then within this I'm going to choose modifier M1. And then for the value to set, I'll choose loop iteration number. And then to make sure that the parameter LED updates correctly, I'll add an action to reload the LED listeners. And then add a final action at the end of this, which will exit the reaction at this point. I'll name this action block find device name, save position to modifier M1, and then collapse this block so it's out the way. And now I'll add a second action block. Because of the exit action in the other action block, this block will only ever fire if the other action block doesn't find a matching device name. In here, I'm simply going to add the action to reload LED listeners again. This ensures that the LED listeners will update even if no matching device is found. And finally, I'll name this block actions for when matching device is not found. And I'll collapse that and the listeners. So we have 3 listeners and 2 action blocks. I'll save this reaction, save the script, and generate the script into Ableton. And then I'll reload the script. So now I should be able to control the first parameter on the auto filter on the selected track, regardless of where it's positioned in the device chain. And I can move these around. It seems there's a problem. When I move the devices within the chain, the reaction isn't updating the modifier, so it's still controlling the device which was in that old position. When I change tracks, it updates correctly. But then if I move the auto filter, it's not updating. So we're missing a event listener. So I'll go back to my reaction, and in the listeners section, I need to add a listener which will listen for when the selected device value has changed. In the path menu, I need to select selected track. And then reload this in Ableton. And now I can move the devices around and it will still control the auto filter. Everything I've shown you in this tutorial hasn't required writing a single line of code, but if you're familiar with coding and are happy adding your own Python code in your MIDI remote scripts, CSS has a few options which allow you to do this within reactions. You can switch menus to custom code, where you can enter your own Python code. You can do this by selecting Custom from the menu options. You can switch an entire action, condition, loop, or listener to custom code. Or you can even use a separate file called the user.py file, where you can write your own Python scripts and integrate it into your CSS script. We have a separate video which covers this in more detail. The link is in the description. In this video, we've covered all of the major aspects of Control Surface Studio 3, giving you the knowledge needed to create Ableton MIDI remote scripts for your own MIDI controller. If you don't already have Control Surface Studio, click the link in the description to go to the Remotify website and purchase it right now, and start building your own powerful MIDI remote scripts for Ableton Live.